Welcome to my channel, a little bit about everything. I've been doing some 3D printing lately and I decided to purchase some TPU. I read up on the uses of TPU. Some use them as rubber tires, like for RC models, remote control models, or as oil seals or gasket material, right, as a seal. And TPU stands for thermoplastic polyurethane. It's the toughest of the elastomers used for O-rings. Okay, it has a temperature range of minus 54 degrees Celsius to 100 degrees Celsius, or if you're Fahrenheit, it's minus 65 Fahrenheit to 212 Fahrenheit, okay, on the positive side. And it's characterized by high tensile strength, excellent abrasion resistance, and tear strength. Okay, so it's not as heat resistant as nitrile. Like there are many types of O-rings out there used for different applications, right? But TPU can be used for hydraulic applications that anticipate abrasive contaminants and shock load. Okay, you can use it in these applications. That's where, in modern day, that's where they use polyurethane gaskets or TPU O-rings, right? This test, I'm gonna print an O-ring out and use it in a certain application where I'm going to cut out a groove and embed the O-ring, and then I'm going to have a lock nut with a portion of it that's going to be cylindrical, a smooth cylindricity, so it'll actually seal up against the O-ring. And you see this normally like in flashlights where they want to waterproof the battery compartment. That's just an example, okay? So I'm going to try this out. I might make it to test pressure. If I can jimmy rig or figure out how to put a pneumatic coupler at the end of it that I can hook up an air hose and see if it holds the pressure from the compressor, which will probably be around 100 psi. I think I can go up to 125 max on my compressor. So that might be part of this video. Okay, so without further ado, let's get on with the project. I had to recreate this test model. What you see on top is the O-ring in red. This is the TPU I'm trying to test out for sealing purposes and what qualities it possesses and how good a seal I can obtain, because the print is layered. It's not smooth. um, the outer portion of that O-ring, once printed, is not smooth. So, does this permit cracks? Does this permit leakage? I don't know yet. But what I had to redo is I changed the threaded area. I changed this design, right? I made, on this design, I made that where I will actually have the gland, or the O-ring groove, I should say, and the threaded portion is going to be on top. Okay? And I've made the clearance between the inner diameter of the cylinder and the screw type, or the screw portion of it. I made it, I believe, to be 0.5 millimeters or 20 thousandths of an inch for a loose fit, because the tolerances when you're printing aren't quite the same as you would have with metal. It's hard to obtain these dimensions unless you've done 100 or 200 prints and you repeat the same conditions and you can tweak it just right. So if I go through the timeline, I started out with a sketch with the surface that seals the sealing area, and then from there, for some reason, I had to create another offset plane so that I could do another sketch and this sketch was for the threads. So I made these to be 1 3/8 threads, national course, 6 threads per inch. Right, I put the threads on these area right here. As you'll see in my next step. And if I go to edit this feature, you'll see it's 1 3/8. The pitch is 6 threads per inch. Unified national course thread, and I chose a 1B. B is for holes and A is for bolts, or on the exterior of cylinders. And you want to model this, because once it's modeled you can print it. If it was just visual and you went to print it, you would get a smooth surface and no threads. So you have to model it in Fusion 360. So next, I created another sketch inside here to hollow the rest of it out. And I had around from here to here to hollow out, like 3/4 of an inch maybe, which is not important, it's just a chamber, so I can put water in it or compressed air. And then I created another sketch to make that pilot hole, and I extruded it and did a cutout. So if I look this way, I should see right through it, right? And then next, what's this? I think I made it into a component. I think that's what that is. Yeah, I made it into a component. Body component. And And then the bolt, I call this the bolt. I started creating it by creating a sketch onto here, right there. If I see, and this diameter is 0.5 of a millimeter smaller than this diameter here. See? It's starting to take shape. So this is 3/8. It's not 0.5, it's the 1 3/8. I'm going to back this up to make sure that I'm telling you the correct information. The outer ring of this is 1 3/8. Yeah, it is the threaded portion. So there's your thread, and from there another sketch, and I built up this smooth area and put a groove in it, or an O-ring groove. Chamfered the edges over here. And then I created another offset plane. I'm not quite sure where it went. Oh, it's in here. So in here I created the cutout tool for the groove. You can do this in two ways. If you had a cutout view of the dimensions, you can create a sketch and revolve it around. I think this is the revolve tool right there, see? If you create a sketch, you can revolve around a certain axis. But that's not how I did it. And from here I created the section with the knurls in it, or the grooves to help you actually twist this cap in and out. There's the groove roughing, and here I created a sketch, and I'm going to use that knob, or that portion, for a cutout tool. See? And then I did a revolve. Oops. I created a pattern, circular pattern. A few chamfers, and the chamfer is anywhere where this piece can actually, see, I made a chamfer on that edge and on this edge, so I don't clip. Oh, I made a little chamfer on here and here, so when I put the O-ring on, I don't clip it and destroy the seal before it's even got a chance to do its work, right? And last but not least, I created the O-ring. The O-ring was just a simple command, and it's a torus. If you look previously on the pages at the beginning of this video, I have the specifications for that seal. Okay? What I'm iffy about is, when do you use a 1/8 diameter or cross-sectional area, a 1/8, or if it's a 1/4 of an inch, or like I made this 1/8. What was stopping me from making a 1/4 of an inch? Was it overkill, or how much pressure can a seal take? What decides what O-ring to use? Right? There's got to be a criteria, because I doubted that a 1/8 thick O-ring could actually handle extreme pressures. So they probably use a 1/4 of an inch thick, or a radius of a cross-sectional area to be 1/4 of an inch instead of a 1/8. It must provide a better sealant and hold higher pressures, right? But I couldn't find a chart that specified what to use as a diameter or cross-sectional area for certain pressures. It will give you certain types like nitrile, neoprene, a whole bunch of different types of O-rings you can get out of different materials, but it wouldn't give you where to use it, the pressure settings, requirements of I couldn't find that portion of it, that information. Okay, so I'm going to send this to, or save this model as an STL file, so then I can send it to Cura. I know that this, if I go into tools and I went to make, I go 3D print, right? And let's say I want to print the O-ring, so I'm just going to clear the other pieces and just print the O-ring. It did the mesh. I have 19,090 little triangles composing this piece. I'm going to send it to Cura, but it's not going to get there. My cursor's searching, and Cura was never activated. So I know Cura, if you bring an STL file to it, it's going to slice it up and do it for you. But I'm just going to print the O-ring as solid and go to File. If I right click on this, it'll say save as an STL. Right? It has to be a component though. So save as an STL, and then I'm going to highlight the bolts, do the same thing, and create an STL. I think it has to be selected though as a component. Now if I right click save as STL, this is the beginning of the cylindrical portion of the test model for the TPU, and it's printing out the bottom layers, and I'm not sure how many layers it's going to lay down before it starts the infill. I think it's 3 or 4. It's up to 4 layers now. It started printing on the 4th or 5th layer the infill, and it's on a triangular basis. Oh no, sorry, it's a square. They're squares or parallelograms. Cubic, I think it's called. Well, it says it all. The cylinder did not adhere to the build plate or table. Somehow something either got cool, or I'm not sure quite what happened. Maybe somebody turned the air conditioner on or something, but I was not able to complete the print, and it was almost finished. That is the screw bottom, and there's the O-ring seal surface, or the O-ring groove. That is the cylindrical portion of it, or the main body. This plug will be fitting into it, so it should have a smooth surface, and then some threads, and then a chamber, and then a peephole, so you can put in your air hose adapter. Keeping in mind, this is just a test piece, right? To see what kind of strains I can put on that TPU. You always got to make sure that your bobbin is free going, that the filament is not going to tangle up, because let's say your filament tangles up, it'll pull in the bobbin, and that thing will keep on printing, and no filament's going to come out of it. So you're going to get this space, like maybe that much, where it completed the print, but there was no filament coming out. And since it never broke off, the machine doesn't know. Don't forget to subscribe. On the last print I did, I got a bird's nest at around this point in time. What I did differently with this print was, I noticed that the bed might have been set to 0 degrees, I'm not sure, and I had no brim around it. This is the final product. All that test piece just to test out the sealability and the strength of this TPU. But if it can hold water or fluids, even though that the print isn't doesn't have a smooth finish on it, if it does work under compressibility, then it has a purpose. And what I'm talking about is, I don't know if I can get it to focus. But since it's printed in layers, it's not smooth. So can fluid get by that or not? Or air, or gases for that matter. There it is installed. Right? And now I've filled this up with water, and I've screwed in the cap with the TPU O-ring. Okay, now I'm going to add pressure to it slowly to see what happens and how long it takes before it leaks. Okay. Right now there's 20 pounds on there. There's 20 pounds, 30, 40, 40 pounds, there seems to be some bubbling here, and actually some bubbling through the seams here. You can see some bubbling here. That's 40 pounds. I think what's happening is you would have to print this at a much finer resolution if you want a tight seal. That's 50 pounds. Lots of bubbling going on. 60 pounds. That is 70 pounds. 80 pounds. Lots of leakage. 90 pounds. That's 100 pounds. That's 100 pounds per square inch. The material itself needs to be printed at a much finer resolution. The print itself is holding up, but it's porous. That was at 20% infill. Maybe at 35% infill it wouldn't leak. You can see a little bit of leakage there around the rim right here. So to get an airtight seal, you would need instead of 0.2 width, maybe a little smaller, 1.5. One 1/1500ths of a millimeter, right? And that's still at holding at 100 psi, right? The seal might be holding up. It's just the material's too porous. So you have to go to like 35% infill and try to get a tighter weave. Yeah, that's the trick. This is only at, I think it's 20% infill. I'd have to go like to 30, 35 to get in there tight. It's like I said, you can almost see the ridges on, well, I can see the ridges on the O-ring here. And every ridge is a possibility for a leak, right? And same here. But it was holding 100 psi and I was getting bubbling around the rim here. So this material itself has porosity in it because the weaving's too loose, right? There's a little tearing there, but that's probably from rubbing up against the seam here. I gotta figure out how to stagger these joints. I think Cura permits me to do this.